Okay. All right, so let's write above this how bearings work. Have you guys ever talked about bearings in like physics or any science classes? Planes, boats? No? Okay, so if something has a bearing, I'm not talking about a ball bearing, a bearing of like, let's say 75 degrees, you start north and then you go clockwise 75 degrees. So this would be 75 degrees. So this right here, this is the bearing. And north is always stable, of course. We reference it on paper just as up, but you know, when you're actually looking at cardinal directions and using a compass, north is only one way. So it makes sense to start at north. Okay, so north and then bearing like that. So what if it was this? Draw this on your paper and show your partner. A bearing of 330 degrees. Draw a quick sketch on your paper and show your partner. Are there no pencils in the back?
There's 2 pens, but they're both dead.
Neat. Which one of you is Mari's partner? All right, if you did it right, it should look like this. Here's north. You're gonna go around, let's see what, this would be 270, whole way would be 360, so maybe like this. This is the bearing right here. Almost all the way back to the north. You guys getting it right? Yeah. Okay. All right, so now we are going to, believe me, these problems can be absolutely infuriating if you don't take it slow. So we're going to take it slow. We're going to be calm. We are totally not bothered by this kind of problem. Totally not. Here we go. Radar stations A and B are on an east-west line 3.7 kilometers apart. I can draw that. All right, so I've got an east-west line. Maybe I'll put it in the middle. East-west line. Here's station A, here's station B, and they are 3.7 kilometers apart. Station A detects a plane on a bearing of 61 degrees. All right, I'm going to draw north for station A. Now, from station A, what is the bearing to B? No. 90 to B, right? Not to C, because C was in the problem B. So like if I was at station A and I was looking at the north, and then I turned myself 90 degrees, I'd be looking at B. Everybody understand that? So now what it's saying is that station A detects a plane on a bearing of 61. 61 is maybe like, what, like that maybe? Over here somewhere is C. So I'm just gonna draw approximately a line maybe like this. This is 61 degrees right here. This isn't a perfect drawing. Station B simultaneously detects the same plane on a bearing of 331 degrees. Okay, so here is station B. Station B is going north, right? If I went around like this, look what I'm doing, and I went to that far, if I said, what's the bearing from B to A, what would you say? it would be 270. Because 90 would be looking that way, and then 180 would be looking down, and then going this way would be 270. You guys agree with so far? Okay, but we're looking at 331, so maybe like this.
We'll talk to Mrs. Anderson.
Okay, where those two meet, it's okay if they overlap a little. That's C, because that's where it is. We need to have some measurements in here, though. How can I add some measurements? Who's got an idea? Yeah?
You can do the angles and taking the nice and north, it's like 90, you can figure out. I guess like 61, it's a 90 degree.
Oh, you're saying I could figure out this inside one?
Mhm.
Yep. Let's see, 60, 29 degrees in here. Okay. What else could I figure out? B, this one was what, 331? So, and up here is 360. So 360 minus 331, this is also 29 over here maybe? Which makes this one, is this one also 61? How about this angle?
Minus 1, 9.
So 180 minus 29 minus 61 is 90. What are the chances that this would be a right triangle? In a right triangle section of the notebook? I wonder if we're going to use SOHCAHTOA. Probably not.
How did we get 61 degrees from E?
So we knew that it says that the bearing is 331 degrees, right?
Oh,
So this bearing is 331 degrees. So then I thought, okay, if it went straight up, it would be 360 degrees. So I took 360 minus 331 and found out this angle right here is 29, that one.
yeah.
And then these two together add up to 90. I guess I could have also taken 270, 331 minus 270 to figure out what this angle would have been. Okay. See how these drawings take a while, but once you got it, you're like, oh, we're doing another right angle? This is how it's always going to be. By the way, if on any of these problems in this section, if you draw the picture and you don't end up with a right triangle, you did it wrong. Okay? There's going to be a right triangle somewhere. All right, now it says, find the distance from A to C. It looks like we're trying to find this one. All right, ideas. Go ahead.
Cosine.
Cosine. So wait, this is my hypotenuse?
Yeah.
Hypotenuse and adjacent. Are you using 29? Okay, so the cosine of 29 equals ca x over 3.7. Nice. Will, you want to finish it off?
Then you cross multiply
X equals
3.7 cosine 29.
nice. What does it turn out to be?
3.24
3.24 what?
kilometers.
Kilometers. Go get a prize. Nice job. Okay. These are hard to draw, but once you draw them, the math's not too bad. All right. Now we're going to try a harder one. There's two ways that people do bearings. If it just says a bearing, it means start at the north, go clockwise until you get that degree. But sometimes it says stuff like this. North, 47 degrees east. Thank you. What this means is that you look to the north.